Good day guys, and thank you for joining us. So in today's lesson we'll be taking on the other half of math called trigonometry. So to get trigonometry started, we're going to get introduced to what is probably going to be one of our best friends when it comes to trigonometry. These are going to be our ratios, okay? And so our ratios go as follow. We have sine, so that's one of our best friends. We have cos, and we also have tan. Cool? So sine, cos, and tan will always come with this attached to it. It's called theta. And basically what theta is, it's a placeholder for any angle, okay? So any angle, say if it's 66 degrees, that degrees would come in the place of theta over here. And so we need to know also what sine, cos, and tan are equal to. So to do that, let's have a triangle so we are able to visualize what we are doing. So we have a right angle triangle over here. In that right angle triangle, we'll always have a theta or a position, right? That's going to be the fraction or the angle that we're working with. Cool. So here is theta. As you can see, theta is also attached to sine, cos, and tan. So how do we need to identify what the names of the sides of the triangle are, and how we do that is as follows. We know obviously that opposite the right angle is the hypotenuse. Then we also know, so that opposite the angle that we're dealing with, so we're dealing with theta over here, opposite theta is the opposite side, okay? And then we have the adjacent side here at the bottom. So there's always going to be two sides touching the angle that we're dealing with. That will be the hypotenuse and the adjacent side. So the adjacent side is obviously the side that is not the hypotenuse. So what we need to know now from this is that sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And then tan theta is equal to opposite over adjacent. So you can see how we're using the different sides of the triangle in our equations over here. And also what is going to help you really remember this, and it's quite neat what we're about to learn here, is SOHCAHTOA. Cool. So what SOHCAHTOA is basically saying is, so this S over here stands for the sine theta. So we write in here sine theta is equal to opposite over hypotenuse, that O and H, right? So that's opposite over hypotenuse. Then we have K, so for SOHCAH, we have obviously the C over there stands for cos theta. And that is A and H, which is adjacent and hypotenuse. So that's adjacent over hypotenuse. And then lastly we have TOA. And we know that that T stands for tan theta, which is equal to O and A, that's opposite and adjacent, so that's opposite over adjacent. So that's just a neat way for us to remember what sine, cos, and tan equal to. So let's just get into an example that can help us sort of understand how to apply this work. Okay, so here we have a triangle on a Cartesian plane over here, and they give us a right angle triangle, and here they give us theta over there in that position over there, and they give us y, r, and x. So in this case, if they asked us to write out the values or find sine, cos, and tan in terms of r, y, and x, so this is how we go about doing it. The first thing we want to do is identify the different sides of the triangle. So here is our theta, right? Opposite our theta, that is going to be our opposite side. Then we have the right angle triangle over here. The right angle over here. Opposite that is our hypotenuse, and then obviously the leftover side is the adjacent side. So what we need to do now is write out what we're trying to find, which is sine theta. Sine theta. Once we do that, we need to write out, okay, what is the equation of sine theta? We know it's opposite over hypotenuse. And if we go to our triangle now and find that, we have our opposite, which is y, and then our hypotenuse, which is r. Cool. And that will be your final answer for sine theta. Moving on, we move on to cos theta. Cos theta, we know that is equal to adjacent over hypotenuse. So now we'll go ahead and look for those values and substitute them in. Our adjacent is x, and our hypotenuse is r. Then we move on to tan theta, which is opposite over adjacent. Our opposite side is y, and our adjacent side is x. And that is how we apply sine, cos, and tan, finding those values, right? Moving on, we're going to move on to another thing that we refer to a lot, which is going to be our reciprocals. Cool. So our reciprocals are basically, what I like to call them is the inverted versions or the inverses of our sine, cos, and tan, and you're going to see why in just a second. So our reciprocals are, let me just get a different color for us quickly. It's going to be cosec theta. Then we also have sec theta and cot theta. Cool. So cosec theta is basically the inverse or sine inverted. So how we write that is 1 over sine theta. And then sec theta is 1 over cos theta, basically the inverse of cos theta. And then cot theta, you guessed it, is the inverse of tan theta. Cool. So let's see how we can apply this to the triangle that we had just before. So we'll bring this example down to here, and we're going to try and find these values. So let's just see how these how our reciprocals relate to our ratios. So if we had sine theta over here, sine theta is obviously, as we know, opposite over hypotenuse. To change it to cosec theta, which is obviously the inverse, how would we write the inverse? Obviously we just switch around the numerator and denominator. So this will become hypotenuse over our opposite side. So instead of looking for opposite over hypotenuse, we're getting hypotenuse over the opposite. Cool? So we can do that quickly. We can just write here, we're looking for hypotenuse over the opposite. So let's go and fetch those values now. Hypotenuse is r, and our opposite is y. And if you can look here, when we did sine theta, we have y over r, but when we're doing cosec theta, which is the inverse, that's r over y. And so now we can do the same thing for our sec theta, which is the inverse of cos. So cos we saw was adjacent over hypotenuse, so now we're obviously going to be looking for hypotenuse over adjacent. And if we get those values, our hypotenuse is r, and our adjacent is x. So now obviously when it comes to one over cos theta, we're going to be looking for, if cos theta was adjacent over hypotenuse, we're going to be looking for hypotenuse over adjacent. So let's go and fetch those values quickly. Our hypotenuse is r, and our adjacent is going to be x. And as you can see, we can confirm the x over r, and this is r over x. Now we'll move over to the inverse of tan theta. So if tan theta was opposite over adjacent, that means cot theta is going to be adjacent over opposite. So our adjacent is x, and our opposite is y. And just like that, we've now covered ratios and reciprocals. Let's go ahead and do an example for both of these. So here in this example it says, write down each of the following in terms of a, b, and c. So there we have a, b, and c, and what's in the fraction is, I'll just write this in color coded over here so it's easier. Theta is actually in this position over here, and what we have in the position over here is alpha. So what I'm going to be doing is also showing you guys how to apply the triangle when our angles are in different positions. So we'll do theta first since we are familiar with it. So we're going to write here tan theta, which we know is equal to opposite over adjacent. And if we go and fetch those values, opposite is c. So let's just go and identify quickly. Opposite is over here, adjacent is here, and hypotenuse is over here. Remember, because opposite is opposite the angle. So let's go and answer. Our opposite is c, and our adjacent is a. Cool. So that is tan theta's answer. Then we're going to do cos theta's answer. So cos theta we know is adjacent over hypotenuse. So our adjacent value is a, and our hypotenuse is b. So that's a over b. Now we'll move on to sec theta. So sec theta, we write out our equation. Obviously we know it is 1 over cos theta, the inverse of cos theta, right? So if we're not looking for adjacent over hypotenuse, we're looking for hypotenuse over adjacent. And our hypotenuse is B, and our adjacent is A. So you can see it's the inverse of cos theta, right? Now we'll move on to cosec theta, so cosec theta is 1 over sine theta. And so if we're not looking for opposite over hypotenuse, we're looking for hypotenuse over the opposite. So the hypotenuse is B over the opposite of C. And just like that, we've applied our reciprocals and ratios in an example. Anyways guys, that's going to do it for our introduction lesson in trigonometry. I hope that this has helped you to understand our foundation work for trigs, and I hope to see you in the next one. Have a good day.